But the theme for tonight's reception is really a combination of the very new and the established, in that we're now celebrating the launch of flexible and printed electronics, our latest addition to the materials portfolio, and also the 10th anniversary of the Journal of Biomedical Materials.
Flexible electronics is a field in which many researchers, many visionaries, many technologists believe is the future of electronics systems. And this is not something you can really buy today, but with research over the next maybe 5, 10, or 15 years will become a practical technology that will be suitable for wearables, stretchable.
I think I've talked to a lot of people who've worked in like flexible electronics before, specifically in like medical devices. So even though I don't work on that, I think that's an interesting idea.
In our world of electronics, we do not like to work with lithographic-based products because that needs a lot of steps to make the product. It's much easier to do it by a printing process where you simply put the product down where you would like to have the product. And that makes it very flexible and it's easy to upscale the whole thing.
Because of all the Air Force requirements, we think this is the way to go, and that's why we are so excited about all these thin film transistors and on flexible substrate and so forth.
Something that can really change our future ubiquitously.
Well, I work with biosensors, and the idea of printing electronic biosensors on a piece of paper, it's something that has the potential to revolutionize point-of-care diagnostics because it will provide disposable devices that are also very high quality. So you have high quality, potential high quality for diagnostics at low cost.
So if we want to make these films over a very large area, we need to be able to manufacture them arbitrarily large. So there's been a lot of progress in this. In addition, the properties of these materials that have been synthesized have been very attractive. So only recently, even in the past month, we've seen results in which these materials can now afford wireless connectivity. So this is very important if you want to make a smart device that can connect to the cloud and retrieve information. And so that's a very exciting development.
One of the main things we're doing is we try to make upscalable organic electronics. So we're working on solar cells, we're working on OLEDs, we're working on these new perovskite-based solar cells. And what I'm trying to do with my team is to make technology which is making it possible to upscale the technology in such a way that we can make square kilometers of solar cells, of OLEDs, and of all kinds of other printed electronic applications.
So what I work on is thin film superconducting electronic devices. Basically what that means is trying to reinvent electronic devices like the transistor using thin film superconducting materials like niobium nitride. You know, we're in like the foundation for these superconducting devices. It would be interesting to see later on, once they're kind of developed, if we could make, I guess, like superconducting flexible electronics.
We have heard this morning the talk by Professor Zinam Bao, the conference, and she showed us results about artificial skin and the capability they had to simulate electronically the sense of touch. So that was very interesting, and it's a very neat application of flexible electronics.
The prototypical two-dimensional material has already penetrated the marketplace in terms of products. So I have here with me actually a smartphone that uses graphene as a touch panel. Oops, just 1 second. So this smartphone sold already, they've sold I think more than 50,000 units, has integrated graphene as a touch screen panel. So when you touch it, it's a graphene interface as opposed to the traditional thin film material. So it just suggests a great progress in this field over the last 10 years.
I'm doing research on dye-sensitized solar cells, more specifically on printing titanium dioxide inks on flexible substrates for dye-sensitized solar cells or perovskite-sensitized solar cells. So even though dye-sensitized solar cells can be produced both in rigid substrates as well as flexible substrates would enable more affordable means towards greener sources of energy.
A few words about why is this effort, this new journal needed, and why we think it's definitely the case that a journal like this it's important for the community. Well, the idea, the project behind this is really that there is no such a journal out already, and the particular feature is that it's really truly interdisciplinary.
I think the journal is very timely. There's really no journal specifically focused on flexible electronics and technology, and perhaps that was due to the fact that the field was not at a critical point. But now that the field has grown, it's worldwide, there's a lot of researchers, a lot of industries interested. I think having a platform for this field is very important.
I think the journal is a nice showcasing thing where people working in the same field can see what printing technology can do for them. So it's not only about printing about my products, but also printing of biosensors, which is not my field, but they can learn from the experience we have in the field of printed electronics, where they do a slightly different printing, slightly different application where you don't need the same technology.
This journal really sets the stage for a true interdisciplinary, for the development of a true interdisciplinary